Hello learners, welcome to Sure Question Academy. Please watch the videos, like and subscribe to the channel.
Let's solve this physics problem on concave mirrors. Part A. An object is placed in front of a concave mirror of focal length 12 centimeters. If the distance of the object from the pole is 8 centimeters, determine the position of the image formed using the mirror formula. Also, draw a labeled ray diagram to justify your answer. Let's solve part A. Mirror formula is 1 by F equals 1 by V plus 1 by U. Given focal length F equals minus 12 centimeters. Object distance U equals minus 8 centimeters. Using the rearranged mirror formula, 1 by V equals 1 by F minus 1 by U. Substituting the values, 1 by minus 12 minus 1 by minus 8. Simplifying the signs, minus 1 by 12 plus 1 by 8. To get the LCM 24, multiply the numerator and denominator of the first term by 2 and the second term by 3. This gives minus 2 by 24 plus 3 by 24. Combining the numerators, minus 2 plus 3, all divided by 24. This simplifies to 1 by 24. Taking the reciprocal, image distance, V, is plus 24 centimeters. The positive sign indicates that a virtual image is formed behind the mirror. Here is the ray diagram. Since the object is between the pole and the focus, the reflected rays diverge. Extending them backwards forms a virtual, erect, and magnified image behind the mirror. Alternatively, let's look at the OR question, part B. First part. The image of an object formed by a mirror is real, inverted, and has a magnification of -1. If the image is at a distance of 30 centimeters from the mirror, where is the object placed? Give reason to justify your answer. Given magnification M equals -1. Image distance V equals -30 centimeters. We know the formula for magnification is M equals minus V by U. Substituting the values, -1 equals minus of -30 divided by U. Rearranging for U. U equals minus of -30 divided by -1. So, U equals -30 centimeters. This means the object is placed at a distance of 30 centimeters in front of the mirror. For the image to be of the same size, real and inverted, the object must be placed exactly at the center of curvature, C. Now, for the second part of part B. Where would the image be if the object is moved 15 centimeters towards the mirror? Draw a ray diagram for the new position of the object to justify your answer. As the image is formed at the center of curvature of the mirror, the radius of curvature R is -30 centimeters. Therefore, the focal length F is -15 centimeters. If the object is moved 15 centimeters towards the mirror, The new object distance is u dash equals minus 30 plus 15, which is minus 15 centimeters. This means the object is now at the principal focus. Using the mirror formula to find the new image distance. 1 by v dash equals 1 by f minus 1 by u dash. Substituting the values. 1 by minus 15 minus 1 by minus 15, which equals 0. Taking the reciprocal. V dash equals 1 by 0. So, V dash is infinity. Here is the ray diagram. When the object is at the focus, the reflected rays are parallel to each other, meaning the image is formed at infinity. Thank you. Happy learning.